Okay, ladies and gentlemen, we're going to look at, this is a continuation of 5.5. We're going to look at how to solve a log equation this time. We're going to start with some very simple ones. But one caveat I want to give you, whenever you see that you're solving a log equation, you have to automatically know to check the answer. And the reason is, a basic log curve either looks like this or this. That's your basic log curve before we start moving them around with shifts and translations and all that stretchings and that type of stuff, okay? You have an asymptote here at the line x equals 0 in both cases for your basic log curve. What that means is the only kind of numbers you're allowed to put in as an argument to a log function are numbers that are positive. So, once you're done solving this equation, what you have to do is you have to go back, and you don't even have to show me, but you have to visually check to make sure that this number is not 0 or negative, because if it is, that answer is going to have to be thrown out. Okay? So anytime you see a log equation, you have to check it because of the potential domain restriction that you can't disallow. You have to check it to make sure. And we're going to see some equations that come out to where one of the answers you may have to throw out, and I'll explain why again. Okay, but basically right now this is in log form, and I think what we should do is convert it to exponential form. It's a good way to do these problems. So we have the log base 5 of x is 4. Remember that 4 is the answer, and the answer to a log function is an exponent of the base. So 5 to the 4th power equals x. And that's pretty much done. I believe 5 to the 4th power, 5 raised to the 4th power is, yep, okay. So the answer is actually x equals 625. And it checks because when I plug 625 in here, it's not 0. It does not make this argument become 0 or negative. So we're good on this one, okay? So what do you do with a log equation? You convert it into exponential form, and then at the end you make sure that you're not violating the restriction that you have in domain when you're dealing with log equations. All right, let's look here. I see the log of, I'm going to write it a little bigger. I see the log of x is equal to negative 2. Remember, when you see the common log, you're automatically seeing base 10. So when I convert this into exponential form, this is going to say 10 to the negative 2nd power is equal to x. And remember, negative exponents take reciprocals, so 10 to the negative 2nd is 1 over 10 squared, which is the answer 1 over 100, or as a decimal you could write 0.01. But 1 over 100 is fine. And the reason this answer is acceptable, when I go back to my original equation and I plug 1 over 100 in here, it does not make this argument become 0, it does not make it become negative, so it's an acceptable answer. Okay? So when you're solving a log equation, there's two things I want you to do. Convert it from log form into exponential form, and then check your answer to make sure an argument of a log function is not ever allowed to become 0 or negative by your choice of answer.